Welcome back, everybody. This is going to be our lesson Algebra 2, linear functions, the linear modeling homework review. And so this one is going to begin with the first question here. Which of the following would model the distance d a driver is from Chicago if they're heading towards city at 58 miles per hour and started 256 miles away? Now, as a linear function, one of the things we know is that, because it's told linear, that we see in this case the model the distance d. So d, of course, is going to be our dependent variable. And of course, we're trying to figure out it says here, t would be our independent variable. So we want to figure out really d of t. And it says a driver is from Chicago if they are heading towards the city at 58 miles per hour. Now, this 58 miles per hour, the rate is equal to the slope of the function. Okay? Because a lot of times we use whole y equals mx plus b setup. But we have to be very careful, because how far is the driver from Chicago would mean that as time continues, he gets closer and closer. So that would mean that although we're starting at 256 miles away, and starting usually is going to be our y-intercept. And so the idea is that when t equals 0, we're going to be at 256. So that rate of 58 miles per hour, that's going to be, in this case, reducing the distance, meaning it's going to cut into the distance from Chicago. So instead of being positive 58, it would be negative 58t. Every hour, we're decreasing the distance away the driver of Chicago. So that would be, really, we could rewrite this as 256 minus 58t, and that looks like, well, here, this choice here, number 2. So d is equal to 256 minus 58t. And here, with the idea is that we're looking for the rate, because it's a linear function, the rate will be the slope, and our starting value when t equals 0 would be a y-intercept. Okay? But we also have to consider now what is happening in the function. Is our value getting higher or lower as we continue over time? So number 2, the cost C of producing X bikes is given by C is equal to 22X plus 132. So this is going to be, they're giving us the cost function. And the revenue gain for selling X bikes is given by R equals 350X. All right, where if the profit is defined by P equals R minus C, then which of the following is the equation of P in terms of X? Well, P is going to just take the R value, so P equals R minus C, we replace R with 350X, so it's just a substitution here. And then we're replacing the P, in this case C value, with 22X plus 132. Well, we're going to shoot a negative 1, because really it's negative 1 here. So we can get 350X minus 22X minus 132. And so combine 350 minus 22 should give us 300 and I believe 28x minus 132. And this will be our value of P. So we take a look here, and the one that matches up would be choice 1. P equals 328x minus 132. Now for question number 3. The average temperature of a planet is expected to rise at an average rate of 0.04 degrees Celsius per year due to global warming. The average temperature in the year 2000 was 14.71 degrees Celsius. The average temperature C is given by C is equal to 14.71 plus 0.04x, where x represents the number of years since 2000. So what would the average temperature in the year 2100? So in this problem, we're given what the formula is going to be, what the average temperature would be, given number of years after 2000. So we establish in this case that x, because here's our formula here, so the year 2100, well, 2100 minus 2000 is going to be 100, and therefore x is equal to 100. So that's how we know what to plug in. We're not plugging in 2100, it's how many years, since x represents the number of years since 2000. And so now we plug into our formula. C is equal to 14.71 plus 0.04. Now, instead of x, we plug in 100, which means we're going to get 14.71 plus, now 0.04 times 100 is just going to be 4. And therefore, the answer should be 18.71 degrees Celsius. And so that's the answer for 3A. That's the average temperature expected to be in the year 2100. Okay? Now we continue on to our next part, part B. Again, we want to keep track of that formula. Algebra determine the number of years x it will take for the temperature C to reach 20 degrees Celsius. And so here we're given 20 degrees Celsius as the C value. All right, so now instead of putting C equals, we know what C equals to. It's going to equal to 20. So 20 equals 14.71 plus 0.04 x. So we solve for x, and so our first thing to do is we'll subtract 14.71 from both sides. And so now I can bring out a little space here. So now 20 minus 14.71 will be 5.29, and that's equal to 0.04x. And so now what we do is we divide both sides by 0.04. So 5.29 divided by 0.04 is equal to x. And so we take our calculator and we take the value here. We're going to get 5.29 divided by 0.04, and we get 132. So x is equal to 132.25 years. Well, it says round to the nearest year. So it says round to the nearest year, and we have to really read the instructions carefully, make sure we get the right answer. So in 132 years, the average temperature will equal 20 degrees Celsius. Okay, according to our formula, right? Okay, so again, we have to read our instructions carefully. Oops. Let me just erase that part here. So, sorry, these trademarks are kind of throwing me off a little bit. So, there we go. All right. Now for part C, and of course then part D. So part C says sketch a graph of the average yearly temperature below for the internal interval 0 is less than equal to x is less than equal to 200. Be sure to label your y-axis as a scale as well as 2 points on the line, the y-intercept, and 1 additional point. Well, to find the y-intercept, what we're going to do is we're going to just take that from the function. Well, c is equal to 14.71 plus 0.04x, and just when x equals 0. So when x equals 0, we have in this case the coordinate 0, comma 14.71. And so now we have our first coordinate. We want to find our second coordinate, right? And probably going to use when x equals 200. So that will be helpful for us. So now what we're going to do is just do c is equal to 14.71 plus 0.04 times 200. Well, 0.04 times 200, well, if it was at 100, it was 4, so 200 would be 8. So now we have 14.71 plus 8, which we add together will be a total degree measure of 22.71 degrees. So that's our second coordinate, 200, comma, 22.71 degrees. All right, and degrees here. Okay, degrees. Okay, and so now our y-axis really is going to be C, our temperature, and x is number of years. So in this case, you have temp here, temperature in Celsius degrees. Okay, and so and here we're x in years, years from years since 2000. All right, so since we're going from an interval from 0 to 200, well, here's our 0 value here, and I guess let's make this 200 here. I like, again, splitting stuff in half, 50, and there's 150 here. And so we have, in this case, we have our initial value, or in this case, when x equals 0, our temperature is going to be 14.71. So I'll make increments of 10, 20, 30 degrees. Okay. And so we begin with our first temperature here. And so I'll make this red. And so we'll draw us at 14.71 is somewhere over here. It's almost 15. Okay, so that's our first point. And then at our second point will be, in this case, at 200, 22.71. So here's 200, 22.71, somewhere over here. Well, kind of. That's kind of like okay there. Maybe I'll lift up a little bit so I can do that. Just thinking about this program here, I can move around things a little easier than maybe something else I used before. Okay, so I'm going to connect these 2 points here with the little line segment. And it's a line segment because, again, only interval from 0 to 200. We're not going past that. So there you go. On your graph, I recommend also that you post the coordinates because, well, honestly, it's, that they're kind of like estimates. So let me put the little smaller font here. So our first coordinate here will be at, we said 0, 14.71. All right, and let me lift this up a little bit here so you can see, or a little down here. And this coordinate, it'll be at 200, 22.71. Okay, all right, so again, this is our sketch. Now, is it a perfect looking sketch? No, but you want to label coordinates so in this case. And in this case, the reader will know the 2 coordinates you used, and of course, your scale hopefully will work out fine. Now, finally, for last part D, we have here, what does this model project to be the average global temperature in the year 2200? Well, we actually found that array. So let's lift up a little bit here, give myself a little room. We found that temperature, and because in the work we did here, because 200 years, because that's what it really is, because 2200 minus 2000 is going to be 200. Our average, the average temperature, average global temperature, will be, in this case, 22.71 degrees. Okay, that's the predicted value. Let me make this full page here so you guys can see everything. Okay, and so this is the end of question number 3 and going to be end of our first video. Hopefully this is helpful to you guys. And please, in this case, make sure you leave comments or questions. It's going to look a little jagged because I had to make cuts and stuff like that, some edits. Things didn't go out the way I wanted to originally, so apologize if it looks a little like broken up and pieced together like a Frankenstein video. But again, please leave questions in the comment section below. Like the video if you found it helpful, and of course, subscribe to our channel if you have not done so already to be alerted when new videos are added. Thank you so much for watching. Take care and be safe.